Okay, we ended up with dynamic equilibrium. That's where we should be on our notes. Okay, on rates of reaction. We're going to finish up our notes today. Okay, and then when we finish up the notes, the rest of the time you can use to work on your lab, finishing it up. Make sure you do a really, really good job. 3 sentences for each conclusion. That means each experiment gets at least 3 sentences. And you need to do an error analysis on each of them, and then an overall error analysis and conclusion. Okay, huh? What things could have gone wrong with that experiment? And then overall, what things could have gone wrong overall? Okay. What could have skewed the results? Good, yes. It's 3 molar, it's fairly strong. Why?
I don't know. I didn't feel it.
Okay. All right, so let's talk about this. Yes, sir. The lab needs to be turned in by next time. Okay, so we get this day to sort of finish it up. I do have colored pencils over on the side, so you can do colorful graphs and make it all pretty. It's a 200-point lab, guys. You want to make sure that it's written up well. Okay, you make sure it's written up well. So if I think there was just one turned in last time. I did not correct it because I want to make sure. Actually, it's a freezing point depression lab, so it's okay. I didn't correct it because I thought it was the other. I want to make sure you really do a great write-up on this one because it's 200 points, and that's a big chunk of your lab, okay? All right, so what we learned just now is, doing that little activity that we just did with the water bucket, is we learned that not all reactions go to completion. No matter how hard she tried, even though she had a bigger bucket or bigger beaker, she couldn't get all the rest of it out before some more came in, right? It didn't go like a combustion reaction. It didn't go, boom, done. Okay, it had reaction going both ways. So not all reactions go to completion. When we have some things that start at different places, we don't always end in the center like this one. We don't always end in the middle. We often end like this, one bucket bigger, one bucket not so big, right? So where is my equilibrium point? It is right where it starts to level out, where they both become the same. That's equilibrium. A lot of kids get messed up and say, well, isn't this equilibrium where they're together, they have the same thing? No, that just means at that point there's the same amount in both buckets. That doesn't mean I'm moving the same amount from bucket to bucket. Does that make sense? Okay, it's important that you understand that. Okay, so next page, going forward. For me, it's next page. Whoops, let's go back here. Okay, so on this one right here, what we need to look at is heat. So heat can be put into the reaction. Now, it can be written several different ways. I can put this as a delta H equals positive 30 kilojoules after the reaction. And I need to know where that goes. If it's positive, that means I have to add in heat to make it work. That means it goes on the reactant side, okay? Or I can have delta H equal a negative 30 kilojoules. Negative means it's giving off. So in that one, I'm putting heat in the product side. I need to know where to put heat. Okay, so they can give it to me a couple different ways. They can just tell me heat, or they can give it to me in an actual number. And you need to know what that number, what that positive or what that negative means. Positive means I have to add it in to make it go. Negative means it gave it off. Okay? And that's important for the next thing we're going into. I can write heat, or I can actually put the number in here. Right into the equation, I could have actually put the number. Okay? So if you see a number in an equation that's balanced, you go, what's that doing in my equation? That's heat. Okay? Now, we're going to talk about why we need to know that coming up. We did the bucket demo where we moved things back and forth. When both participants were transferring water, what happens to the amount if I had one side large and the other side small? It equaled out if I was using the same size beakers. But if I change the size of the beakers, what happened? Depends on what side I had the big beaker, which side I had the small beaker, right? Okay, so when transferring container, this is also part in your notes. This is in your notes too. When transferring container is changed, so when I change to Poor guy's got the small beaker. The girl's got the big beaker. And so what happened? We ended up with a lot more in the small beaker, the one that was trying to get the small beaker bucket, than we did in the big beaker bucket. Okay? When transfer reaches dynamic equilibrium, what was true about the amount being transferred from this either bucket? It was the same. Make sure you're writing this down so you don't forget it, so you get credit for this. Remember, these notes are worth points. Okay, so we get what's called Le Chatelier's principle. Okay, Le Chatelier basically gave us some things to tell us what happens. So if I put a stress on the system, like I took out 2 containers full of water on one side and then I had to do it again, the equilibrium changed. It shifted. That's the same thing that's happening here. If I add reactants, it's like I'm adding a pile of dirt to my yard. Well, if a pile of dirt came to the yard when I was growing up, all us kids had to go and help spread it out. It didn't stay as a pile of dirt in the middle of the yard. So that's how I think of it. So if I add reactants, add things to the reactant side, guess what? It shifts this way to the right towards the products. Okay? Now, same kind of thing I'm thinking in my head when I was a kid. If somehow I tended to dig somewhere and make a hole, my dad would come home and he'd get mad and I'd have to fill up the hole, right? So if I take out reactants, then I'm going to shift towards the reactants to the left because I got to fill up that hole that I just did by pulling that out. Okay, so I'm shifting. Okay, now think about it. If I take and remove the products, I'm making a hole on the product side. Which way is it going to shift? I got to fill that hole. Remember, you've got reactants that are on this side, and products are on this side. Okay, so if I take out products, which way is it going to shift? If I take out products, I'm making a hole on this side. I'm going to shift to the right. Good. I'm going to shift to the right towards the products. Yep, you shift towards the hole. Did you guys not find what? It's in there. Yeah, well, it might not be. We might have run out. It was in here. It's the daily work, and there's... Okay. So I have to sometimes crisscross them up and down, so sometimes they're shifted down. Okay, what if I add to the products? I'm making a pile on the product side. Got to spread it out. What am I going to do? What way am I going to shift? I'm going to shift to the left toward the what? Reactants. Okay, the next part has to do with only gases. So when I'm looking at a reaction, I look at the gases for this part. If there's no gases, volume and pressure have no effect. Okay? But if there's gases, there is an effect. Think about when you open your pop. What are you doing when you open a pop bottle? Releasing the pressure. I'm making the pressure go down. What happens over time if I leave my pop out? It goes flat. That means all the gases come out of it. Okay? So if I release the pressure, it goes to the side that has more gas. If I put it in pressure, put the pressure increasing on it, what happens? I go to the side that has the least amount of gas because it goes back into the liquid. Okay? So, temperature, this was the heat thing. This one, actually, the temperature doesn't just do gases, it does everything. This is the heat thing that we said earlier. So it's going to follow this. So heat's basically going to follow. If I put more heat in and it's, let me do a little thing here. Exothermic, what does that mean? Releases heat. So it's going to be on the product side, right? And so I'm going to put a little product under here. If it's on the product side, it's exothermic. And this all has to do about heat. What, and then delta H would be negative. Okay? If it's endothermic, where would heat be? Reactant side, good. Okay, so it will follow this up here if you know what the heat is. If it's a reactant or a product, it will follow what we just talked about. Okay? Pressure and volume, though, those are the ones that have to do just with gases. Okay, let me extend this up a little bit. Okay, so if I increase the pressure, okay, then I go to the side with the least amount of gas, the least number of moles. Okay, if I go black, if pressure goes down, and this would be, if pressure goes up, volume's going down, and if pressure goes down, volume's going up, okay, this would go to the side with the most number of moles of gas. Okay, so let's look at this. What if I have the equation we've used a lot? H2, which is a gas, plus O2, which is a gas, giving me H2O, which is a gas. Is it balanced? No. I can look right here, 2 oxygens, 1 oxygen. Oh, I need a 2 here, and then I need a 2 here. Okay, now looking at this, how many moles of gas do I have on the reactant side? How many moles of gas do I have here? I have 2 moles of hydrogen and 1 mole of oxygen, so I have 3 moles of gas. See that? So 2 moles of hydrogen, 1 mole of oxygen, 3 moles of gas. Okay, everybody okay with that? So how many do I have on this side? Okay, tell me which side it's going to go to, reactant or product, if I increase the volume. The 3 side. Why the 3 side? Has more moles. So if I increase the volume of something, I give it more space. I've opened up the pop bottle. The gases are going to be produced. It wants lots of gas when the volume goes up. Okay, so what if I increase the pressure on it? It'll go to the water side, the side that has the least amount of moles of gas. What if I decrease the pressure? Which way? Show me with your fingers which way you're going to go. It's going to go this way, right. Okay, what if I decrease the volume? Decrease the volume. Show me with your fingers. Decrease the volume. If I decrease the volume, I'm increasing the pressure, so it's going to go to the side with 2. Okay? So this is your assignment number 3, what's going on in it, but we're going to have more time to do that. Okay? So let's go on to the next one. Here we actually have a reaction. Oh, okay, so from what we just talked about, how many moles of gas do I have on the reactant side? 1, 2, 3, 4. 4 moles. Okay, what about on the product side? Hold it up. How many fingers? How many moles? I have 1 person, 2 people being brave. 4, 2, 2. It's 2. So we have 1 methane and 1 water, so there's 2 moles over here. Oh, what's that? Heat. Okay, so now we've sort of looked at the equation, and decided what all we have in it, right? So let's take and add CO2. Oh, I'm making a pile on this side. What am I going to need to do? What way is it going to shift? Nope, I'm adding CO2, or CO, carbon monoxide. I made a pile over here. Dad came home and got mad. Spread it out, so I got to spread it to the product. So shifts to the left. Oh, yep, right. My other left. I put products. I just don't mind left and right. Okay, now this time, the next time here, I'm going to remove H2. I'm taking this guy out. Making a hole. So I'm shifting which direction? And what's that called? Reactants. Okay, now I'm going to add H2. Making a pile. Okay, I'm going to shift to the left. Good. So this one went this way. I forgot to put these on here. This one went this way, and this one went that way. Okay, so now we're going to go black. I'm going to remove methane gas. Good. Shift to the right towards products. So I'm going to shift this way. Okay, got to pick another color. Aquamarine. I don't know how well it'll show. Add pressure to the system. What's that going to affect? Add pressure to the system. It's going to affect these. Which one am I going to do? I'm adding pressure to the system. Which way am I going to shift? Show me with your hands. I'm hearing lots of words, but I can't see it. This way, this way. Towards the least amount of moles of gas. So the higher the pressure, I go to the smaller amount of moles of gas. The less the pressure, go to more moles of gas. So this one's going to be shift to the right toward products. Pick another color, purple. Add heat. Ooh, which one was heat? Okay, so I'm adding joules, heat. Now what? What am I shifting? Show me, tell me with your fingers. I see only a couple. I'm making a pile here. Dad's making me move it. Move it, move it, move it. Shifts to the left. Toward what? Reactants, good. Okay, so now you've got an example, right? Let's see what's next. Oh, end of reaction, there ain't notes, so you just need to study. So that's the last of the notes for this term. For the whole term, that's the last of them. So what we're going to be doing is we're going to be finishing your lab now. We're going to be finishing your packet of assignments, including your review assignment. You'll be getting another review assignment that has more review stuff on it because this test is going to have more review stuff on it. Because rates and equilibrium and Le Chatelier, there's not much to do there. Okay, so we're going to add some more stuff into there because we're coming up on the SAGE test, which is the end of year test, and you got to get all that stuff we learned at the beginning of the year back in your head. Okay. We'll be taking a test May 10th through the 14th. 2 days each. Okay? All right. Any other questions? lab done first, then work on your assignment sheets, and then your review assignment, and then you'll be getting another one. Okay, now, heads up. I'm going to be here Monday and Wednesday next week. I won't be here Friday, but you're going to get a review assignment on Friday that's going to be really similar to what's on the test. If you have any problems on that review assignment, you need to come in and see me on Monday during tutorial or before school or after school before you hit the test on Tuesday. Okay? So you got to really plan your stuff so you can get a good grade. Okay? Questions? So we got 2 more days of just finishing up and getting everything done. If you have any questions, okay? Wonderful. Get to work. Remember, your notes are going to come in for points. Yes?